Hey everyone, my name is Benji. Welcome to my channel. Here I talk about PCB design, electronics, and a bunch of other stuff through making synthesizer modules. One thing that I found I really like about modular synthesizers is the concept of randomness and probability. Sequenced electronic music can often feel too repetitive, so having a way to mix things up every once in a while really helps to keep your music interesting. One way I like to achieve that is through a sample and hold module paired with a noise source. And that brings us to the project I'd like to show you today, which is my MiniSNH. The core of this module is a sample and hold circuit I got from Moritz Klein's tutorials. It takes any signal like from a noise source or an LFO and another one from a clock or a trigger. It holds whatever voltage level that signal is at every time a trigger is received. This way you get a stepped output that's synchronized to a clock source. The results of that process can be accessed through the SNH output of this module. You can then use that output to control things like pitch or filters. For convenience, I also included a built-in noise source in the MiniSNH. It's just a simple white noise generator that the sample and hold uses if you leave the noise input without any jack connected. Another feature that I added to the MiniSNH is this probability gate output that I like to use to create randomized gates based on a probability knob. It's based on a simple op-amp comparator circuit. Turning the knob to one side increases the chances of the gate firing. I have two gate outputs, one is just the inverse of the other. Once I was happy playing around with the module on my breadboard, I started to design the PCB and the panel. I mainly use KiCad, but this time I wanted to use Inkscape to design the graphics and the layout of the panel itself. I also wanted to try out handwritten labels. I used to make my panels out of acrylic and handwritten labels. I liked that look and I kinda missed it a bit, so I wanted to try it out on PCB. Once the graphics and the layout was done, I used a plugin called SVG to Shenzhen to import my design into KiCad files. I copied those into my KiCad project, then I started working on the electronic component layout. Like my other recent modules, I used SMT for this one. After I was done making the layout, I sent my files over to PCBWay.com, which is also the sponsor of this video. PCB Way has been my go-to for PCB manufacturing. They're really good for prototyping PCBs in small batches like this, especially for hobbyists like me. They've been sponsoring this series of open source Eurorack modules for a while now. All you need to do is go to their website, upload your files, pick some settings, submit your order, and then wait for your PCBs to arrive in a couple of days. Here in the Philippines, they typically arrive after a week or so. Aside from PCBs, they also do 3D printing and CNC, which I would also like to explore in future projects. Let me know if you have any ideas. Again, thank you PCB Way for sponsoring this project. As expected, the PCBs arrived after a couple of days. This was also the first time I ordered a stencil. This is basically a sheet of metal that has holes that correspond to the pads found in the board. This way I could put the board underneath and then slide some solder paste on top. That makes applying solder so much faster. After that, all I'd have to do was to place the components and then apply hot air. Of course, for the through-hole parts, I still have to solder them with my soldering iron. One thing that I'm really happy about in this build is how the fonts turned out. It was strange seeing my handwriting in PCB silkscreen, especially when you have multiples of them. I think I'll keep doing this for my future modules. Of course, this was the first time I'm building the PCBs. So this was also the time that I discovered all the mistakes that I did during the design phase. One thing that I should have seen up front was that the mounting holes were missing. I must have deleted those footprints before I exported the files. When things like this happen, I often have my PC beside me while I'm building, so I can update things in real time. This way, I don't forget the fixes that I have to do. Another thing that I had wrong was that two of the op amps had their power pins flipped, so I had to manually wire them up. I had to grind down some traces. I also found that the sensitivity of the probability knob needs more tweaking, so I added this voltage divider in the form of 2 through-hole resistors. To do this, I had to expose some copper traces using a grinding tool. Good thing I had this microscope, which was sent to me by Link Micro a while back. I also had the gate outputs flipped, so turning the knob to one side actually increases the probability of the other side. That was an easy fix, and I already did the modifications for the next one. Despite all the mods that I had to do with it to get it working, I've already been able to use it in a couple of gigs. I often use it as a probability gate control, which makes my synth skip some beats. I'm already working on a new version that addresses the problems that I mentioned earlier. All of my files are already on my GitHub. I will also update my website as soon as I verify that my fixes in the new version works. The PCBs will also be available in PCB Way's shared project page, where you can order them directly. That would be all for now. Let me leave you with some demos I made using the MiniSNH. Thank you very much for watching, and I hope to see you in the next video.